Okay, here we have a friction problem, so I'm going to sketch this out. This is a block on the floor. The block is 20 kilograms, and we're applying a force of 80 newtons on the block, and we want to figure out its acceleration. Now, if there were no friction whatsoever, my acceleration would be, using the second law, simply 80 newtons divided by 20 would be 4 meters per second squared. So that's if there were no friction. However, there is friction on this floor, and the friction is going to act against the direction of motion, but we don't know the value of that friction. So we have to use this equation, which says that the frictional force will equal mu, that's the coefficient of friction, times the normal force on the object. Now, the normal force, so here's the block, its weight is 200 newtons. The normal force is the force that the floor applies to the block, which in many cases is equal to the weight, assuming that we're not in an elevator or assuming that nothing else is lifting up or pushing down on the object. So the normal force here is 200 newtons. So if I want to calculate my force of friction, it's simply going to be 0.1 times this normal force, 200 newtons. So doing that, I get my force of friction is 20 newtons. So I can replace this here, 20 newtons. So that changes my net force. If 80 is my applied force minus 20, my net force is now 60. My mass remains 20 kilograms. So now I'm going to solve for the acceleration. So it's 60 newtons divided by 20. In this case, it's 3 meters per second squared. So it's a little lower than if there were no friction, but it hasn't changed much because the friction was relatively low. But that is basically how I use the friction coefficient to solve a very basic friction problem. So until next time, I am Derek Genova. Have a delightful day.